So it's good to finally be, be together, albeit virtually. And so thanks for the invitation, and thanks for organizing. So what I'm going to talk about today is sort of tentatively titled Behavioral Macro Models, Expectation and Empirical Fit. And so this is joint work with Chris Gust and David Lopez-Salido, who are my colleagues at the Federal Reserve Board where I work. I guess I should have put my affiliation. One thing I should say before I get into my talk is that, this stuff that I'm saying, obviously it does not necessarily represent the views of the Federal Reserve Board or the system. So don't think that it does. Okay, so this is a conference on the effects of forward guidance policies and sort of understanding these kinds of policies. And we are sort of thinking of we've been thinking about models of expectations sort of prompted by sort of some sort of struggles in the literature to sort of come up with quantitatively believable estimates of the effects of forward guidance policies. And so, I think it's pretty straightforward to understand why expectations are super important for determining both the effects of monetary policy, conventionally and unconventionally. And so, a number of papers today have talked about expectations in these terms. And so, I think everyone has sort of cited, this paper in these papers in the last, 10 years or whatever. But, recently, I think more people are sort of coming to grips with the sort of limitations of FIRE, i.e. full information rational expectations. One manifestation perhaps of this is sort of this so-called forward guidance puzzle, whereby, promises about things far in the future have, sort of implausibly large effects on people's decisions today. And so, recently there's been this sort of, sort of literature, like a series of literatures sort of sprouting up that are, you could broadly categorize as sort of models of imperfect expectations formation. And so, we've been sort of in that literature for a little bit, and, we have a particular angle, and I'm going to talk about that today. So, we're going to look at a particular kind of imperfect expectations formation and sort of compare it with some others. And to some extent, we've sort of, this is a sort of big project that we've been working on for a couple of years now. And so to some extent, we've sort of got things done. And so, essentially, what we wanted to do was first, before we get to, policy, before we get to even expectations, just to think about these models as generating sort of statistical descriptions of, some data series we care about, and sort of think about whether there's a difference in the, sort of myriad of these imperfect expectations formations. And so, we had a paper that's going to be coming out in the AJ Macro that's about looking at this this dimension of a series of these kinds of models. And so I'll talk about the results of that a little bit as a way to sort of frame our current work. And so the next thing that we're doing is we're sort of stepping into this world of sort of thinking about expectations and expectations data directly, and we want to do that in the context of these kinds of expectations formations models, and in particular one kind that we like. Okay, so there's been a ton of work in this area, and I'm sure some people here have done some work, and so it's a really large literature. There's a lot of behavioral macro models, let's call them, that emphasize that people's expectations are sort of rooted not in our the setting of our classical models, but instead human judgment, and in experimental evidence kind of indicates that people are not fully rational or fully informed. And so there's been a lot of work. So there's the limited attention model of Gebex. There's Andrelatos and Leon's sort of lack of common knowledge, Fari and Werning's K-level thinking, the Bordello, Schleifer, and others work on diagnostic expectations. And then there's Woodford's finite horizon planning model. And so that's in red because that's the one that we're going to sort of focus on. And so, as I said, our research agenda was sort of, we're sort of in two parts, and we've kind of got one done and one underway. So, do these kind of models provide empirically realistic macro dynamics and a behavior of expectations? And so, we think that these are kind of necessary ingredients before we start to study the effects of monetary policy. Okay. So I'm going to focus on this FHP model. This is finite horizon planning, and if you haven't seen it, so the backbone of this model is a canonical new Keynesian model. So the key difference is that there are infinitely lived households, but they make state contingent plans over a fixed K period horizon. So they only sort of think fully rationally in terms of the next K periods. And they take, the sort of continuation value beyond that as given. So they do not internalize their effects of their decisions in this K period plan on the future. And so this is a form of bounded rationality. And so, this kind of continuation value, sometimes we call it like a value function. Agents are limited in their ability to sort of estimate this or sort of construct this object, right? It sort of cannot be this kind of completely state contingent, sort of function. And so we describe this as sort of the value function is coarser than, sort of normal in its state dependence. And so the way people are going to update their beliefs is a very kind of simplistic one. Is that they're just going to use past information to update their beliefs about these terminal values, these continuation values, and they're going to use gain parameters, gamma, which I'm just going to refer to these in a few slides. So I'm just like putting them out there now. Gamma and gamma F, and gamma F is for like the firms and gamma is for the households. But the distinction, in sort of this setting is not going to end up being super important. So the classic sort of, or the sort of Woodford FHP model that he sets up has actually some heterogeneity. It's like kind of incredibly rich, given what you sort of get at the end, given how we can boil it down into like 6 equations. But this planning horizon K, different households have different, planning horizons. Different firms have different planning horizons, and the distribution of these horizons is fixed, and it follows an exponential distribution. And that exponential distribution is parameterized by a parameter rho. So when rho is 1, then that means that basically all of the agents, that's a kind of very degenerate distribution where sort of all of the agents in the economy actually have infinite planning horizons. This is like a limiting case. And when rho is low, then that means that there's a large mass of agents who have very short planning horizons, and you can get the average sort of planning horizon by just taking the inverse of rho. So this is another sort of important parameter in these kinds of models. Okay.
Sorry, Ed. Is the heterogeneity going to be crucial here, or can we just think?
No, yeah. So it's crucial in the sense of like, like the algebra looks very nice, but you can do a representative agent versions of these economies where there's like, a single planning horizon. And at least in the empirical work that we've done, we've found that it's not, it's the difference between having this rich set of heterogeneous setup is not, big in terms of tracking, average macro aggregates and thinking about sort of average effects of policy. Now you do get stuff like, you do get, say, disagreements about, things and thinking about the future. And, we looked at this sort of empirically a little bit, and, we found some kind of cool stuff. But but yeah, but I think for today's talk, you can sort of just think about it as like a single kind of horizon of like 2 quarters or something like
Right.
that.
Oh, got it. And perhaps it's coming, but is it the case that after the K period they behave like adaptive learners, so they have a fixed projection matrix and they just iterate it forward?
Yeah, so they use sort of constant gain learning to change their value, to update their beliefs about their value function. And
so they're rational up to period K, and then after K, they just forecast, taking their expectation that their perceived law of motion is fixed.
Yeah, so it's sort of like, yeah, it's, you can think about it as like, it's sort of like the period, it's like their terminal value is sort of like the period utility, say, for the households. And so what they kind of need to estimate is the sort of long run, consumption and inflation. And they're going to do that using constant gain learning. Yeah, so and actually it's right here on this slide. And so like this model is like extremely beautiful from some from just like a presentation standpoint. So what happens, when you sort of add this all up and then you do this sort of aggregation across all these different horizons, is that you get sort of an economy that you can describe in kind of 3 parts. So the first part is like maybe what I'll call like the cyclical economy. And so it's a 3 equation New Keynesian models. We have output Y, inflation pi, and the interest rate I. And we have some shocks, Z, which is like a sort of demand shock, Y star, supply shock, and I star, which is a monetary policy shock. Now you see there are these variables, these corresponding variables to Y, pi, and I, which are just Y, pi, and I with bars over them. And those are trend variables, and I'll talk about them in a minute. But you can see that everywhere there's a pi, there's a subtraction of a pi bar. So you can think about the difference between pi and pi bar as being like the trend or the cycle. And if you squint at this, you can see that this is sort of just the standard Euler equation, the standard New Keynesian Phillips curve, and a standard policy rule written in terms of sort of deviations from a trend, where the trend is now going to be sort of interesting. And the one twist here is that, like, say, the representation of the Angeletos-Leon or Guébet or whatever, you're going to get a discounting in your Euler equation and in this expected inflation term in both in the Euler equation and in the New Keynesian, in the Phillips curve. So you're downweighting the future in terms of these cyclical, this sort of cyclical block of the economy. But otherwise, it looks just like a New Keynesian model, right? If rho was 1, this would look, like a textbook model. And so the value functions, you can sort of write as I said, we're using some constant gain learning as the agent's estimates of the value functions. We have one for the consumers and one kind of for the firms, right? And so it's just my estimate of the value function today is just a weighted average of my estimate yesterday plus some innovation where this is sort of related to the to this, as I said, this like sort of city state utility. And then you can kind of back out, and maybe I've written this in a like a sort of backwards way, but you can then figure out the trend values as being related to the value functions and themselves. All right, so this is just sort of inverting, taking the value function and sort of rewriting it to sort of have the trend variables on the trend, the inputs on that to the left hand side, and so again, when rho is 1, this stuff doesn't matter at all because you're going to have a 1 minus 1 here and a 1 minus 1. These things will all be 0. The other thing I should mention is that, like, I guess like this policy rule is not, this is a policy rule that, we chose. We let the central bank respond differently to trend inflation and trend output, but you could do different things. Like there's not, that's not written in stone. Okay, so it's still in my on our earlier work, but basically we say that we estimated these models on data on output, inflation, and interest rates. So like really old school kind of exercise. And we find that about 50% of the agents plan for the current quarter. So that is a large proportion of the agents in the economy are very short-term thinking in terms of their plans, and that they update their value functions very slowly. And so we think this was interesting. This was like the first empirical attempt to sort of measure this. One thing that jumped out at me is that this model, as someone who does, sort of a lot of, or had been doing a lot of this estimation of DSG models, the model fit is substantially better than both like, the new Keynesian model with habits and indexation and, all that stuff, and other behavioral macro models such as the Angeletos-Leon or the GiveX thing. And so like, again, I want to emphasize here that there's no habits, there's no, sort of the endogenous persistence is coming all through this, is coming through the, through this learning framework, essentially combined with the finite horizon planning. And so, in that paper, we talk about how like the things kind of look okay, like the business cycles sort of match what your prior views of, let's say, what caused the 1984 or in the early 1980s recession, monetary policy in the Woodford model. And then something we sort of pointed to, but we didn't talk a lot about, was like, this trend inflation, it sort of looks kind of like, a measure of trend inflation, of expected inflation rather, that we have in the data. And so here's from our earlier work, we have here, basically inflation. So inflation of the cyclical inflation plus trend inflation. And the model estimate of trend inflation shown in the blue bands. And then we have our estimate of cyclical inflation. And so, it's, we argue in the paper, at least, that it sort of accords with like maybe some estimates of cyclical inflation that come outside of this model. And then we have our estimate of long run inflation with, I believe this is the SPF median 4-quarter ahead inflation expectations. And so like, this is not a perfect fit. It's not, exact, but it sort of looks like the thing that, we sort of thought was interesting. And so in this paper, what we're going to do is go beyond this. And so we're going to focus on this model and other models, ability to fit expectations data. And we're going to focus, like many others have, on inflation expectations. And so, like there's a lot we can do, there's like a lot of inflation expectations data. And there's a lot of dimensions of that kind of data, right? And in particular, we have a lot of survey data, and we have survey data from professional forecasters. We have, some from firms, some from households. We're going to stick with the literature and focus on inflation forecast from the SPF. It's a very long time series, and it's been studied before, so we can sort of have some comparability. And then we're going to focus on the sort of median expectation. So there's a lot of interesting stuff in terms of like disagreement, we've talked about today, or how different people respond differently to different information. Just generally, and again, there is some room for disagreement in the heterogeneous agent version of this model, but we're not going to focus on that today. And so, what we wanted to do was to sort of think about this sort of underreaction and overreaction of inflation expectations that's been talked about a lot. And so, there's a very heavily cited and important paper by Corbion and Grodnichenko, who provide evidence that forecast errors are systematic and predictable. So this is like a rejection of full information rational expectations that is done, outside the context of any model. Which is very appealing, right? Because you're not carrying around all these assumptions. And so just to fix ideas, we've got our forecast errors, which is just inflation minus our forecasted inflation. And then we have revisions, which is just our inflation forecast today minus our inflation forecast yesterday of some particular horizon H inflation. So we're going to use like the 1 year average, which is, I think, pretty standard. And so this coefficient, which is a key part of their paper, is just the population regression coefficient that you get when you regress the forecast errors on the revisions, right? And this should be 0 in a full information rational expectations model. And if it's sort of positive, that means that people are sort of underreacting in general to information. And so, the big thing in that paper is that you can show that for sure you can reject 0. And I think what's more interesting, or not even more interesting, but what's also interesting is that, like, for a kind of a class of models, you can actually derive this coefficient in kind of under sort of general settings, right? And so, like, one example is in the sticky information models, where lambda is like the proportion of people that are allowed to get updated information sets. I think the coefficient here, the population coefficient, is just like that parameter divided by 1 minus that parameter. And so, the first thing we thought of is like, we can just do the same thing. And so, what we did was we took a representative agent with k with a k horizon with a k planning horizon, and then we started to make have and make a lot of assumptions. So we already had to go to rep agent, and then we had to turn off learning, which is a big part of the empirical fit. And then we had to assume that there was a single, this is a univariate model with a single exogenous process with an AR coefficient of delta, or I think actually it's a type 1, should be like the square root of delta. But you can get a population analog under these assumptions. And so, we can show that, for reasonable persistences, deltas, you can sort of get the right coefficient, but we were kind of a little bit disappointed by that because, like I said, there are so many sort of caveats to coming up with this analytic expression. And so, but we said, it's okay, like we're just gonna just keep plowing ahead. And so, another paper which has really been important recently in this literature is this diagnostic expectations of Schleifer and others. And so we sort of tried to do this for the diagnostic expectations model, and we can show that it's sort of even more complicated, and you need to make even more simplifying assumptions. So there's like a key parameter in these kinds of models called theta, which is sort of twisting people's expectations, which of course is going to show up in an expression for this coefficient. But then there are things like the discount factor, the inflation indexation parameter in a sort of hybrid new Keynesian Phillips curve, and more. And so, we were thinking like, okay, this is the second, imperfect expectations model that we looked at, where, basically this indirect inference framework of Corbion and Grodnichenko is going to be difficult because we're going to have a lot of nuisance parameters. And so, my takeaway is that, like, this indirect inference can be sort of fraught if you want to sort of infer whether there are reasonable values of the parameters that can sort of match this key moment that you're interested in. And so in some ways that was sort of music to my ears, because I have a hammer, which is like estimating these Bayesian models, and one solution to the problem of nuisance parameters is to use a full information approach. And so what we decided to do was go into sort of to look at both this, to think about this beta coefficient that our models are telling us, but also to think more broadly about fitting in observed inflation expectations. And so, the kind of cornerstone of the work is we're gonna take sort of the stuff we did before, where we just fit output, inflation, and interest rates, and now we're gonna add to it a measure of inflation expectations. And we're gonna assume that this measure is like sort of noisily, is a mismeasured version of like the sort of model inflation expectations. And so there's a couple of things that I was interested to look at. One is sort of the stability of the parameter estimates with and without expectations data, right? Because if the model is well specified, when you add more data that is sort of generated from the model, or in theory is generated from the model, the parameter estimates shouldn't sort of change that much. They should maybe sharpen a little bit, but they shouldn't, change a lot. And so, there's been work done on this before. One thing that I was interested in was sort of an estimate of the relative fit of expectations data given macro data. And so you can compute this if you're Bayesian using a log conditional data density, which is just a log marginal data density of the joint data set, and the minus the log of the sort of macro variables only data set. And then as I said, we're going to implement what we're going to do to think about this particular moment is we're going to implement this as a posterior predictive check. And so what that means is we're going to basically simulate data from our model, and then compute beta, or beta hat, I should say. And then we're going to compare it to the beta hat that we get when you just run the Corbion-Grodnichenko regression with the SPF data. And the idea is that we're going to now have from our model a distribution of beta hats. And if that distribution, if the actual value, the one that we get just doing the regression on the SPF data, is lying in the tails of the distribution implied by the model, then that model is sort of deficient in that dimension. And this seems to be a very important dimension to look at. So it's important to focus on. And so, I think I'm taking a lot of time, a lot more time than I thought I would. But basically, we estimated this model without expectations data, and then we included the expectations data. So, I've done like a billion of these kind of models. I put 4 here. So we have a hybrid New Keynesian model, a sticky information model, a diagnostic expectations model, and the finite horizon planning model. And so, these are a bunch of numbers. They should have uncertainty surrounding them, but I'm not there yet. The key takeaway is that, without the macro, without the expectations data, this FHP model fits the data better, which is consistent with our earlier work. When we add the expectations data, the model continues to fit better, and the relative fit of expectations data is the best, with the sticky information model sort of not super far behind. The model that does the worst is the hybrid New Keynesian model in terms of fitting inflation expectations data. One thing I want to say is, I just want to look at these parameter estimates, right? And as I said, DSG models have a ton of parameters. I'm not going to have a chance to go through them all. And if I did, like everyone would never talk to me again or whatever. But you can see that, here's a New Keynesian model. Here's our estimate of the slope of the Phillips curve when we don't have the expectations data. It's basically 0. It's like flat, right? When we add, which is consistent with a lot of estimates of the slope of the Phillips curve. When we add expectations data, it jumps up by 3 orders of magnitude, which is it's a big sign that like something is not good with the way that this model, the model's joint distribution of expectations data and expectations and not expectations is not set up, is not capturing what's happening in the data well. You can see it in the habit formation parameter. The monetary policy rule is quite different. This is like kind of not good stuff. If you look at, the decompositions, your understanding of history changes dramatically, which again is like is a sign of misspecification. And of course, the hybrid New Keynesian model is fully information and rational expectations. So this beta parameter, if you use expectations data or if you don't use expectations data, the distribution is centered around 0. Whereas in the actual data, in the actual regression, you get a value of like 1.2. And so, we can do the same with diagnostic expectations. There's a lot of details that go into solving these models. I'm not going to go into it, but the parameter that's sort of key for this model goes from 0.44, so very close to rationality, to 2.9, which is very far away. So again, there's like adding this expectations data does violence to the model in a way that we'll see if it happens in the FHP model. But again, like this model is it's really hard for the model to generate the sort of underreaction that we see in the Corbion and Grodnichenko regression. Instead, in fact, if you don't kind of force this on it, it will choose overreaction to news. So the beta coefficient will be negative. Finally, the Woodford model, and again, like my takeaway looking at this table, after someone who has looked at many tables like this in my life, is that when you add the expectations data, the model is sort of remarkably stable, and so the distribution of planning horizons is sort of it moves a little bit but not much. The monetary policy rule is very similar. The updating is very similar, and so that's like a pretty we were struck by that. Again, if you try to like sort of did the model's interpretation of history sort of change, the answer is kind of no. Like it's it's very similar sort of decompositions in the FHP model when you force it to fit expectations data and when you don't. And then finally, so sort of this beta coefficient, obviously there's a lot of uncertainty in this finite sample exercise, but we get kind of in the right ballpark of the value in the Corbion and Grodnichenko regressions. And again, like we don't actually target this, although we have tried sort of different ways of actually doing that. We're just fitting the entire time series of expectations and actual inflation and a couple of other variables, and then this is sort of what we get out of it. And so my takeaway from all of this, and I'll just wrap up here, is that I think this FHP model as like an empirical sort of device to capture key things in the macroeconomy, sort of it fits, it does surprisingly well, and so we're going to keep working on understanding the dimensions of this problem. But I think for us, like it's sort of passed a number of hurdles that were important for us before we start to think about sort of monetary policy in a way that sort of some other models that we looked at could not. And the next thing we want to do is think a little bit harder about the zero lower bound. Obviously things get a little complicated with linearizations and whatnot, and then think about policy and optimal policy. So so thanks again for listening, and yeah, that's all I had.
Thanks, Ed. That was very interesting. Does anybody have a question? I was wondering, Ed, so do you take the Woodford model as it is? Do you make any changes to it at all in the beginning?
Yeah, so we changed a little bit. We changed where the demand shock was in the model. It's just like a really minor change. We also added a little. I think we added the kind of Fisher shock. We made it like a Fisher shock, so we added that. Like the kind of very minor discounting you get from that. And our idea, like at one point, we were sort of looking at the distribution of like savings, and because you have like if you think about the heterogeneous density model, you have a lot of different things going on, and that's why we did it. I think as in terms of like this stuff, it probably doesn't matter all that much.
Right. Yeah. I am first, to be honest, I'm not very familiar with his model. I have to take a look. But I was pleasantly surprised. Well, not so surprised, but I was pleased that the fit is so good with learning. And I remember Fabio Milani, if I'm not mistaken, he has this series of papers, so 2007 and a bit later, on the full adaptive learning. So I guess, as I said, I'm not really familiar with the Woodford stuff, but it sounds to me that it's kind of a midway between rationality and just complete learning. Do you have any idea why, kind of what's the selling point of that? Does this rationality bias anything above the learning? Because in the Milani work, he also showed that the fit with the macro data was fantastic compared with all.
Yeah, so I guess, I think, I haven't checked the, this versus a full, like kind of a full Milani style learning model. I guess like here, I think maybe some people argue the sort of micro foundations are kind of more grounded in the sense of like, you can rational, like this is like how, like computer algorithm, like this is like basically, as I understand, it's like reinforcement learning. There are some nice things in that this nests a rational model, which I don't think is the case of the Milani stuff, although I'm not a huge expert on that. And so here, we're sort of giving the model a chance to be rational and like really kind of nesting. Well, we have the potential to sort of nest almost everything. And then the third thing I guess is like the way this is set up, and I talked about this a little bit with the learning, how there's like households and firms, and they have different learning rates. They also could have different horizons. And so if you think about setting up like a richer model, you can have many different sort of sets of agents that have different horizons, which I think is maybe empirically realistic. And at the Fed we have this like massive model called Furbis, and it's like often the case that we do policy experiments where the sort of financial markets are more forward-looking than consumers, and that this seems to sort of have that kind of you can do that kind of stuff here and also like have a equilibrium and understand the model compared to sort of the
I agree that the nesting bit is pretty good. I agree. Does anybody want to add something?
And hi, so I really enjoyed it. What would change if you used consumer expectations instead of the professional forecasters' expectations?
So I don't know. I mean, I guess like I don't know if we have I don't know if we have not looked at that. I guess there's like a Michigan survey. I guess we'd have to think about that. There's like probably a bias there that's much larger than the SPF, and like that is going to be that this is not a model where they're going to be bias forecasts, like sort of in a no shock world. And so I have to think about that. That's definitely something we want to do, but we're sticking, we stick with the current literature for now. Yeah.
Thanks.
Ed, I was a bit surprised on the learning gain parameter. It seemed very large, 0.5.
So there's some, so I guess like what, I think like what this is, I need to check whether that's right. It may be the case that I put a restriction in the model that like forced both parameters to be this parameter, although I think this could be right. I mean,
it also depends on the forecast.
This is the household side. Yeah. So this is like, and I guess like some intuition I might have for why that might be is that I think like the the firm's value function is the thing that is sort of really pinning down the long run inflation. I think much more than the households, and that's the sort of variable that's like really persistent. And so, you know, because we're doing this on output growth, and so so like what this kind of stuff does statistically is that, like, you know, you solve a DSG model and you have a VAR1. In the Woodford stuff, if you do that, you solve the cyclical model, you have a VAR1. And then if you sort of undo all of this cyclical and just put everything back in levels, you'll have a VAR2. I think that, you know, the important coefficients in that VAR are the ones that are sort of in the lags, are in the lag is a sort of inflation coefficient. And my sense is like that this is what, you know, this is why this coefficient is so important. I mean, or why this particular coefficient is like estimated to be lower than the household one. I could also say that if you force them to be the same, it's not gonna like destroy the model. Like it will still kind of, you know, work basically as it has, and you know, in terms of like a time series fit, it's like pretty similar.
Right. I guess it depends on the exact learning difference, because I don't think they use mean forecast errors, do they?
Yeah, I'd have to think.
I think it was just the difference, and that could explain also the magnitude, because in the learning it's usually 0.02 to 0.05, 10 times is little.
Yeah, I see. Yeah, I see what you're
saying.
saying. Yeah, there is. So there is. Yeah, I guess like comparing these gain parameters across these kind of different classes of models is probably a little bit difficult when you think about that. But yeah.
Great, fantastic. But that's there was yet another push towards, you know, thinking outside of the FIRE framework, which I always appreciate. But thank you so much. We are just on time. Thanks everybody for joining in. Thanks Ed for the great presentation.